The main focus of this module is going to be on writing procedures that work on scheme lists. So before we do that, we're going to take a brief review of some of the things we need to know before we start working with lists. We'll also see some examples of different ways that we can define lists. So to start off with, we want to talk about the idea of null. Now, if I just type null in the REPL and press enter, you'll notice I get an empty list. So I'll put one in the code as well, just so you'll see it in the output. So if I ask, is the empty list null? And I'll also ask if, let's say, a non-empty list is null, then you can see that the empty list is true when we ask if it's null, but a list with something in it is not null. Now, what about a number? Is a number null? And the answer is false. So far, null is just giving us the empty list. What about 0? And what about false? So you'll notice 0 and false are both not null. So a null is just an empty list. And so we can use that in our list procedures when we check to see, are we at the end of a list? Now, what about this? And I'm going to do this in the REPL, and there's a reason for that. What if I ask if this is null? No, and again, it's because this is not an empty list, it's an empty scheme form. So I'll put this in the notes and comment that out. Again, since this isn't a valid scheme form, it doesn't evaluate to anything, and so we get an error. We don't get true or false. Now, what about an operation? So let's say plus 42. Is that null? And the answer is false. So how about this? What if we ask if null is null, and we'll even ask if the null operation is null. So null is null. That's what we would expect. But the null predicate, of course, is not null because it's actually a procedure. What about this? The car of the list with just one element in it, and actually instead of 0, let me make that an A. So that's false. But if I take this same code and instead of the car, I ask, is the cdr of this list null? The answer is going to be true because I didn't actually type cdr. Now let's change it to a cdr. And you'll notice the cdr of that list is the empty list, which is null. So here, let's say, we'll put that we're asking questions about this. So the car of A, the cdr of A, and then we'll put the predicates below those. And we get a false there because that should be a semicolon, not a double quote. And so you can see A is the car, empty list is the cdr. So the car is not null, but the cdr is. Okay, so that's one thing that we're going to base all of our recursive scheme procedures off of. The idea, if we have a list and the list is empty, that's going to be our base case in most cases. So now let's talk about some list procedures. And before I do that, I'll define a new list to work with called list. And I'll just make that the list 0, 2, 3, 4. So the car of the list and the cdr of the list. And let's also print out what the list actually is. So you can see we have our list, the car is 0, and the cdr is the list with 2, 3, 4 in it. Now I can use cons. Think of that almost as a constructor. I'm going to construct a list out of 1, or let's do -1, and list. So when I do that, I get -1 in front of that list. And of course, if I take this list and take the car of it, or the cdr, too many parentheses there. There we go. If I take the car of that list and the cdr of that list, I get the two things that I made up with in the cons -1 with the list 0, 2, 3, 4. And so the result of taking the car is going to be -1, and the cdr is going to be the list 0, 2, 3, 4. So that's -1 and list. Those are the two things I'm consing together. So car and cdr are the two components of the cons. Now what if I consed the list ABC onto list? There's just one piece here. There's just a list. So that's not good. So if I want to put those together, I need to use append. Append the list ABC to list. And that'll give me the result that I'm expecting. And I can append the list with itself. But if I cons the list with itself, I'm going to get something different. So you'll notice here is append. We have 0, 2, 3, 4, 0, 2, 3, 4. We have 8 elements in this list. But when I did the cons, I have 5 elements in the list. The first element is going to be the list 0, 2, 3, 4, and then the second element is 0, third is 2, and so on. Now what if I append list with cons list list? There we have 9 elements. The 4 elements of list as a single element in its own list. Then the remaining elements are the 4 elements of list again. Now what if I do this? Cons list 4. Well, I get this weird syntax, and we'll see later in this module that that's a pair. And actually, let's make that 5 so that our list makes a little more sense. So maybe I want to do append list 5. Well, if I do that, I get this. Still not what I'm looking for. So what if I cons list with, and here I'm going to be clever, I'm going to make a list with 5 in it. Notice there we have 2 elements, list and 5. So we're getting close. If we want to put 5 at the end of the list, we want to append list with list 5. So these last 4 examples are important to understand what difference those make, because in your code, you'll sometimes accidentally get into one of these scenarios, and you want to make sure you're choosing correctly between cons and append. Okay, so let's see a couple ways that we can make lists. And what I'll do is I'll actually define these lists instead of just seeing what they evaluate to, and that'll let us work with those later. So the first thing we're going to do, I'm going to define example list 1 to be plus 2, 3. I meant to do a string there, not a comment. Did I do that somewhere else? Those should be strings. So let me fix that real quick. And that should actually be a comment. I guess that's what threw me off. Okay, so I think those are good. Let's get back to creating lists. So here we have a list with 3 things in it, but remember, we're not quoting it, so we might not get the result we expect. And of course, we don't get anything because we never evaluated that list. So here we get 5. Again, remember, this is an operation, so it's going to evaluate this. If I want to make a list with those things, I need to quote plus 2, 3. And I don't need that first parentheses. So example list 2, and you can see it has plus 2 and 3. Now you may think, okay, I know what I can do. I can take the car of X list 2, and I can add 10 and 20. But you can't because it's not a procedure. So let's do X list 3. We'll define that using the list operator. And we'll say plus 2, 3. And when I do that, I can take the car of X list 3, 10 and 20, and that's going to work. So let's run this, and you'll see X list 3, the first element is the procedure plus, then 2, then 3. And so I can pull that car of that list off. That's an operation, and that operation gets applied to the operands 10 and 20, resulting in 30. So let's do another list where we cons plus to cons 2. Let's just do 3 as an empty list here first. And then let's do this slightly differently. Well, cons plus to cons 2, and we're going to cons that with cons 3 with the empty list. And one more. Let's do this exactly the same way, but instead of the empty list, let's say null. So here, let's put 3 here. So here we're consing 2 with the list with just 3 in it, which would give us the list 2, 3, and then we're consing plus to that. Here, we're consing 2 to this, the list, and this cons 3 with the empty list will put 3 in the empty list, so that gives us the list with 3 in it. We cons that with 2 to give the list 2, 3, which we have the plus symbol, not the plus operation in front of. And this, we're doing the same thing except null, except the empty list in that innermost cons. So if we run this, we're using the wrong name, which reminds me I need to actually put these out. So you can see these are all the same. Again, though, the symbol, not the operation. If I want the operation, so let's snag this one, and we'll make that 7. What if I just put the plus sign there? And when I evaluate X list 7, now you can see that the procedure's there because I didn't quote out the plus sign. So now, if I want to make a list with 2, and then the result of adding 2 and 1, you'll see that that doesn't work because I misspelled the list operation. So when I do that, I get the list with 2 and 3 in it because it evaluates this. Again, that's as opposed to if we did something like this. With 9, we'll use the quote symbol, and then we'll do a 10th list where we use the quote keyword. And let me actually evaluate these so that I can actually see what they're doing. And when I run that, you see that in this case, for 9 and 10, this plus doesn't get evaluated because we're quoting what's inside the parentheses. So there's really not a whole lot of difference between example list 8 and if we did something like this where we just say list 2 and 3. So what if we do this? What if we define 12 to be the list with list 2, 3 in it? So you'll notice here we have 2, 3, which I think it should be what you would expect. And then when I add list to the front here, notice I get the procedure list. Okay, so let's really kind of go with some extreme stuff here. If I say list 2, 3, list plus 2, 3, plus 2, 3, think for a second about what you expect this to evaluate to. And again, I would recommend pausing the video, trying to think about what this will be before you see this. Okay, so let's run this. And we get the procedure list, which is this, a 2 and a 3. Then this evaluates to the procedure plus 2 and 3, and then 5, because that's 2 plus 3. So this gets evaluated, but it returns the list with these 3 items in it. This gets evaluated, and it's evaluating the addition operator, so you're going to get a plus. So in our last example, what if we quote list 2, 3, list plus 2, 3, and plus 2, 3. So if we quote that, you can see that we get the symbols. It's basically exactly these same characters. The list symbol, 2, 3, list, plus symbol, 2, 3, and so forth. So again, it's important to understand what happens when you quote versus what happens when you use list to create something versus what happens when you use const to create a list. So we're seeing 3 different ways to build a list. And it's important that you have a good handle on this before we start actually implementing procedures that work on lists. One other thing is there's a length. So let's say length 1, 2, 3, 4, 5, 6. And let me spell that right. Let's say this. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So xlist2 has 3 in it, which, okay, I'm sure that's correct, but I don't remember what that list is. Maybe we should have displayed it. So yeah, this will make it easier to be sure that this is giving us the correct answer. So this is of length 3, 1, 2, 3. This is of length 2, 1, 2. And both of these are of length 6. So maybe that might be a good thing to do to make sure that there's 11 numbers inside. But the length here is 11. The length here is 1, 2, 3, 4, 5, 6. So this whole list only counts as one element in the outer list. So just as a reminder of what example list 1 is, it's 5, and xlist 2 and xlist 3. So you'll notice we have a plus and a procedure that uses the plus symbol as the first member of those 2 lists. So just as a reminder, if we say car of xlist 3, and then let's give it 10, 20, and 30, it gives us 60, because again, this is the car of xlist 3 is the procedure addition. This doesn't work if we did this for 2, because there we just get the symbol. So let's just demonstrate that. And you'll see we get an error. This is not a procedure that I'm trying to apply to the parameters here. But xlist 3, since it actually is a procedure, we can pull that off our list and then apply it however. So I can do something like this. Car xlist 3, the catter of xlist 2 with the cadder of xlist 2, and that's going to evaluate to 5, because this is the plus operation, not just the symbol, it's actually the operation. This is going to give us the cadder of xlist 2, which this is xlist 2. So the cdr is 2, 3, and the car of that is 2. So this is going to give us 2. And then the car of the cdr is 3. So this evaluates to the plus operation, not the symbol. This evaluates to the value 2. This evaluates to the value 3. And so when we run this, we get 5. 2 plus 3 is 5. Again, some of these hopefully we'll review from last time. There were probably a few new topics, but all of these are important because these are things we're going to use over and over in our list procedures. So it's important that you have a good grasp of those now.